So this is all three of my parts of my midterm project. So the first one, we are simply just doing taking import input from the user, uh, which is going to be the product ID and how much the quantity of a product that is sold. We're going to reference that within the program uh, of the constants that we have for the price, and then we're going to use that to figure out the total price and the total quantity sold. We're using this calculate total later on to get the total price. Um, and then we're also using these constants, as I said, and these counters for each product. It seems a bit chunky, but it kind of keeps everything a little bit more organized as we step through this switch statement. This if product length is equal to 0, that's making sure that the string input that we get from the user, the end user, uh, is only one digit. If it isn't, if they try to input, say, 2 and 5, we're going to tell them we only want the ID first and then it, just to make sure the input is put in exactly as we'd like it. We're going to switch it to char, just make it a little bit sexier, um, and then send it through the switch statement. And then we're just going to ask for the product sold and put that into whichever product case we're in. So if it's 2, we're going to add it to 2. Pretty simple stuff. In all the cases, we're then going to clear the input string, essentially, and then grab the next product ID until we hit the terminal value, which is 0. So it's 1 through 5 and then 0. After all of that, we are then going to call our calculate total on products 1 through 5, add all of that to the total price, and then add all of the product counts 1 through 5 to our total quantity, and then print a little pretty line, and then the total quantity and then the total retail price with a little bit of formatting with the print. Scrolling through to see if I missed anything, and I don't think I did. So, saying that to say, if I pull this up and we run it, let's say call it 5 and 3, let's say 2 and 3, let's say 4 and 2, let's say we actually put in 6, please enter valid, wonderful. So let's say 1 and 2, so what do we have? 5, 2, 4, 2, 1, and 10, and 0. So if we look, 0, excellent. Okay, moving on. So this one is going to be an account balance system. So essentially, we're going to need 4 types of input. Well, not types, but we're going to need 4 bits of input from the end user. We're going to need their account number, the account type, the minimum balance, and the current balance. The minimum balance is going to tell us whether they exceed or are under the minimum balance. If they're under, they're going to incur a fee, and if they are over, they're going to get a percentage added. Now, the account type is going to be an S or a C. We're going to check for both the upper and lowercase value, and then if the account number is less than 5 digits, we're also going to send the warning value and make sure that the input is correct. We're going to have a couple constants, 3 of them exact, the checking breakpoint, that's going to come into play later, I'll explain that in a moment, and the checking charge, 25 for checking. That's going to be the fee subtracted if they are under that minimum value. If it's a checking, and saving charge is 10, same concept, just with saving. New balance we set to 0, but that's going to be added and reinitialized or reevaluated as we move forward. A lot of these are just validation checks, as you can see. So when we get the account number, we want to check and make sure it's the right type of input that we need. So we won't let them move past if it's not. Same thing with the account type. If it's not S, uppercase or lowercase, or C, uppercase, lowercase, we won't let them move past it. For the minimum value, if it's not a positive number, we won't let them move past it. Excellent. So, if it's a savings account, we are going to check if it's greater than the minimum balance. If it is, then we're going to add a percentage to the current balance and then add all of that, or excuse me, we're going to multiply the percentage to the current balance and then add all of that to the current balance and set that to the new balance. Great. If it's not, then we're going to subtract the current balance from the savings charge and then make that the subtract the savings charge from the current balance and then make that the new balance. Cool. And we're also going to give them a little warning message as to why we're doing what we're doing. Excellent. And then in both cases, we're going to make sure I didn't do anything crazy. In both cases, we're going to print that out. Excellent. Similarly, with the checking account, we're going to do a lot of the same stuff, except the only thing different is we need to check for this breaking point, which is going to manage whether we have a 3% or a 5%. If it is less than or equal to the breaking point, we're going to multiply it by 3%, which is 0.03, or 5% if it's over the breaking point, which is 0.5%. Which, if we run all of that, let's say it is, that's our account number. We have a savings account, minimum balance of $1,000, and we have $5,000. Wonderful. So this one is going to be a parking meter checker, essentially, a parking garage check. So this one is going to test parking fees for all the customers in a garage. Now, a couple assumptions. There's a maximum fee, a minimum fee, and a maximum limit of 24 hours, and nobody's exceeding the 24 hours. With that out of the way, we are going to say that we also know that anything under 3 hours will get that minimum of $2, and anything over 3 hours will anything over 3 hours will get charged 50 cents an hour or part thereof until it reaches $10. That's where that maximum comes into play. Now, knowing all that, that's where we get the minimum charge 2, max charge 10, and min hours 3. Okay, that's where these constants come into play. And this is where the double charge, individual charge, good stuff, the double fees, the vector, which is a dynamically mutable array. Excuse me. And this is going to come into play because basically for prints and a really pretty printed list for later, while we can change the charge and kind of empty it as we go, if we add that charge to the fee, we can then step through it again with a for loop when we're ready to print everything. It's gorgeous. Total charge, by the way, we can accumulate that and have that final number show up as a running total and again at the end. We're going to have a counter start at 1 so that when we print it, we don't have to keep track of anything else. We can just say, hey, this is customer 1, customer 2, customer 3. Great. So out of all of this, the only thing we need from the user is the hours parked. So if the hours parked is less than 0, we're going to say, hey, enter some valid numbers, because you can't park less than 0 or else you're not in the parking lot. Great. If they are less than 0, if they're greater than 0, we're going to start kind of backwards. So this is saying if we're greater than min hours, if they're not greater than min hours, we're going to set charge equal to min charge. Great. That's saying if it's less than or equal to min hours, we're going to say it's $2, and we're going to add that total charge. We're going to add that charge to total charge. Good, cool beans. If it's greater than min hours, we need to take the min hours minus the car parked, minus the hours parked. We need to multiply that by 50 cents and add that to the minimum charge to get our charge. Kind of complicated, but stay with me. Because say it's 7 hours. Well, we need to take the 7 from 3 to get 4, right? So it's 7 minus 3, that's 4, because those are the chargeable hours. And then plus the 2. So it's going to be 4 times 0.5 plus 2 to get our charge. Now, we're doing all this until that charge is going to be over 10. So charge equals, but before we leave this and go do anything else, we need to run one final check to see if it's greater than max charge. Then we just need to cap it, say charge equals the max charge. We need to absolutely make sure that it's not going to exceed 10. And then again, after all of those, in any case, we need to just charge plus equal total charge. Or total charge plus equal charge, meaning total charge equals total charge plus charge. Wonderful. And then we need to increment our customer count. After we print all this, all pretty, and then give us another prompt, add the fees charge, and add and get some more hours parked. When we get our terminal value and we exit the loop, then we're going to print our fee elements again, or our fees out, element at right here, which gives, let me try it. When we exit the loop, we're going to step through our fees vector, and we're using the fees element at so that we can call the vector at that specific element. So, excuse me, that specific index, so that at that index it's going to be that charge that we're looking for. And that's why we're adding it to it individually. That's a lot. I'm tired, but it's going to look like this. So let's say 5. Cool. Let's jump all the way to 18, 19. So that's 10. Let me show you 20. Okay, it's still 10. Wonderful. Let's drop down to 2. Wonderful. And let's go to 0. And then it prints it all out. The exact same numbers, just a little bit prettier with a pretty print. Okay. That should be everything.